Okay, it's Mr. Rops here, and today we're going to talk about Voronoi diagrams. And these are actually new to the applications math class. And so I've just been learning about them too. I've never actually studied before, but they're actually really cool. And they're used for different scenarios with like that. It can model territories of animals. So imagine you have like solitary polar bears that they want their own territory. And so if this is the polar bear's, it maps his region out, and so this is as close as they ever get, and it's equal distance to each other. Or you might decide upon the best place to open a new restaurant or school based upon where the other schools and restaurants are, or perhaps place a distribution center. Imagine if these three sites here are Starbucks chains. Where do you place your distribution center so that it is equal distance to all of these stores? Or it could also estimate rainfall in regions. So you could, if this site here was 21 centimeters of rain, then you could assume that all of the region in here would also have 21 centimeters of rain. And so it's a way to estimate rainfall or snow or air pollution or content of the soil, like lots of different scenarios this could be. And so just to define a few things for us so that we're all speaking the same language, what we have each of these dots are called sites. Okay, so those are sites, and they could be restaurants, they could be animals, they could be measuring devices. And then the lines are called edges. The area inside where the site is, this is called a cell. Okay, and then where these edges all meet, these corners here are called vertices. So one is vertex and the corners are called vertices. And the way that these Voronoi diagrams are created, they are created by perpendicular bisectors. And so if we take two sites and we create a line, we put the midpoint on, and then we go perpendicular to it, this is how all these sites are created. So let's talk a little bit more about perpendicular bisectors. Just to refresh your memory, a perpendicular bisector is a line that cuts a segment into two equal parts at a right angle. Okay, and so if we consider this scenario, so we have these 2 points here, and if we're going to make a perpendicular bisector, I consider the midpoint between A and B, and then I make a line perpendicular through it. So that's the perpendicular bisector. And what happens is these two purple segments are exactly equal. So if you look down here, they're both 3.61. Now, one of the cool things about a perpendicular bisector, no matter where my point goes, these distances, these purple lines, are always the same. And so even here, it is equidistance from A to C as C to B. So if this is the most simplistic Voronoi diagram where I have two sites, and if I want to divide these sites equally so that they are equal, find the boundary where they're equal distance, well, the boundary where they're equal distance is this line here, the perpendicular bisector. And so any point on this side with A is closest to A than B. Anything on this side is closest to B. So if you were standing where my pen is here and you were really thirsty and A and B were watering holes, you would walk to B. It would be closer to go to B than it is to A. And so that's another thing that you can work on for Voronoi diagrams. You're close if you're in the cell. So if you are in the cell here, the closest site is whatever site is in that cell. All right, so perpendicular bisectors cut the line in equal parts, and what you have to remember is that if a point is on the perpendicular bisector of a line segment, then it is equidistance from the endpoints of the segment. That is exactly talking about these distances here. These distances are equidistance